We are finishing up the last section of chapter 2 with topic 2.8. Some of this is going to sound very familiar if you paid attention in geometry class, and some of it's going to be a little bit new because I know that you did not probably go over part of it in geometry class. But we're going to go over the distance and midpoint formulas and talk about circles on a graph, which is interesting things to me. The distance formula, which we learned in geometry class, is the following. Let's go ahead and highlight the distance formula. It's d equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So it's related to the slope formula, but it's really just the triangular distance Pythagorean. If I said slope formula, I meant Pythagorean theorem. It's related to Pythagorean theorem. It's just the distance on the x-axis plus the distance on the y-axis, both squared, and then take the square root, creating like a tiny little triangle for your distance formula. Do y'all remember this sort of from geometry class? Yeah, okay, so let's make sure we remember how to use it. If we're finding the distance between these two coordinate points, we're going to express our answer in both simplified radical form and then rounded to 2 decimal places. You don't have to label your points, but while we're learning, it's helpful. We'll call this one x1, y1, and then x2, y2, which tells me exactly where to put them in the formula itself. So if I start to plug it all in, we'd say the distance is equal to, reading the formula, x2 minus x1, minus a minus makes plus. You know what, I'm going to show the minus a minus because these are our notes so we know where it came from. So minus -1 squared plus y2 minus y1, close parentheses, squared. All of that's going to be square rooted. If it just asks for a decimal approximation, literally you could type all of that into your calculator and give me the decimal approximation. But I'm also going to ask you for the simplified radical form, which means we have to do a little bit of arithmetic by hand. What is 3 minus -1? 4. What is -2 minus 4? -6. So I have 4 squared plus -6 squared. I'm leaving the parentheses there because when you square a negative number without parentheses in a calculator, you get the wrong answer. So we always keep the parentheses. Well, 4 squared is 16, and -6 squared is 36. 16 plus 36 is 52. Is 52 a perfect square root? No. 49 is the perfect square root, that's less than it, and then 64 is right above it. So we do have to actually break this number down. If I break the number 52 down using a factor tree to its prime factorization, the first thing I notice is that 52 is divisible by 2. It's 2 times 26. 26 can be broken down to 2 times 13. Can any of those numbers be broken down anymore? No, those are prime numbers. Do we remember how to break down a square root after it looks like this? What am I looking for? The couple. So I'm going to have a pair of 2's, and you're right. They go outside. What stays inside? The 13. The solos stay inside. So our distance formula here is equal to 2 square root of 13. But if we wanted a decimal approximation rounded to 2 decimals, at this point, you have 2 options. You just take this and plug it in your calculator, or you go back all the way up here and plug this into your calculator. Up to you. I would probably choose this one. So in your calculators, can you do 2 times the square root of 13 and then round it to 2 decimals? 7.21. So there we have both simplified radical form as well as rounded to 2 decimals. I can make that box look nicer. Does that all sound like things we've done before? Fabulous. That's the distance formula. I will ask you to find the distance between 2 points. Period. Okay, now midpoint. Midpoint is another formula from geometry class that most people forget about because it's so easy. Midpoint is like the middle between 2 points. If you had a line segment connecting these 2 coordinate points, x1 and y1, and x2 and y2, then the coordinates of the midpoint in between them is the average of the x's divided, and then the average of the y's. Okay, so if we're following this formula, this is for midpoint. It looks complicated, but it's really simple. This is just the average of the x's and then the average of the y's. So it's really not a formula you need to remember because it's so simple. Average of the x's, comma, average of the y's. So let's say we have a line segment with these endpoints, and we're going to find the midpoint. Again, you don't have to label your points unless that's helpful for you, x1, y1, x2, y2. But if we go and find the midpoint value, all we're doing is filling in this yellow formula. I like to use m with a small p for midpoint. That's not official notation, that's just Miss Quigley notation. But that would be, this is x1 plus x2 over 2, comma, y1 plus y2 divide by 2. So 1 plus negative 8 is negative 7 over 2. Negative 4 plus negative 6 is negative 10 over 2. Can one of those fractions or both of those fractions reduce? 10 over 2. And we're going to leave negative 7 over 2 in fraction form. If I'm ever asking you for decimal, it's negative 3.5, but you know I love my fractions. Oh, I never took roll. Pause here for a second. Okay, how do we feel about midpoint? Is that pretty easy? Average of the x's, average of the y's. Awesome. So the reason that we wanted to kind of review distance and midpoint is because the main focus today is on circles. And you can actually graph circles on a coordinate system as long as you understand the concepts of distance and midpoint. A circle, by definition, is the set of all points in a plane that are equidistant from a fixed point, so same distance, called from the center. The fixed distance from the circle center to any point on the circle is called the radius. So that's a lot. We have a center of the circle, and we have our distance from the center to the edge of the circle, that's the radius. Okay, we know that radiuses are like half of the diameter. We know all of this stuff. But when we're graphing these kind of circles on a number line, oh my gosh, the words are not coming to me. When we are graphing circles on a coordinate plane, we have a standard form of the equation of a circle. What are some things you notice about this equation of a circle? Bless you. What are some letters you notice in that equation? H. What else? K. Where do you think H and K come from? Bless you. They're the center points. So H and K are the coordinates of the center of your circle. What other letter is in this formula? R. And what is R standing for? The radius. So we need two pieces of information to write the standard form, bless you, standard form of a circle. We need the center of the circle, and we need the radius of that circle. With all of that info, we would be able to graph a circle, write the equation of a circle, talk about the domain and range of a circle, all of the things. Oh my gosh, bless you again. That is such a cute little sneeze. Okay, for example 3, we're going to write the standard form of the equation of a circle with center at 0, 0, 0 and radius of 2. Now, this is important information. We have a center of the circle at 0, 0, and we have a radius of 2, which means that our h comma k is 0, 0, and our r is 2. So if I start filling in the yellow formula using those pink and blue numbers, here's what it would look like. This is going to be x minus, bless you, 0 squared plus y minus 0 squared equal to 2 squared. Notice everything's squared, yes? Let's simplify though, because once we plug everything in, we do want to simplify to make this look nice. What is x minus nothing? Not nothing. It's just x. Is that what you meant? Sure. And then y minus nothing is just y. And then 2 squared is 4. This is the standard form of a circle that has a center at 0, 0 and has a radius of 2. If we were graphing this information, all we would need is that center and that radius. I'm going to zoom in because I want to make this accurate. We put the center at the center. Here's 0, 0. That's the center of my circle. Now, humans drawing circles, we're always going to do a mediocre job. So here's how I want you to do this. On the 4 ordinate directions, which means north, south, east, west, up, down, left, right, I want you to count the radius, which means I'm going to go to this direction and put a dot, 2 to the top, 2 to the left, and 2 to the bottom. That's the radius distance all the way around the circle in the 4 ordinate directions. Cardinal directions, that's the right word. Cardinal directions, ordinate directions. Who am I? Then you can play connect the dots and please do better than me at drawing a circle. That's what I did this first time. You can make it look a little bit more circular than I'm able to on this digital thing, you can. But it should be an actual circle, at least connecting those 4 dots together with the center at the center. Is that okay? Can we try another one? Example 4, same vibe. We're just not going to graph this one. This time the center is at -2, 3, and the radius is 4. If we fill in the yellow formula from the top for the standard form of a circle, this is x minus -2, minus a minus, spidey senses should go off, we'll clean it up in a second, y minus 3 squared equal to 4 squared. That's h and k and r. We clean it up. What is minus a minus? Positive. So this is x plus 2 squared plus y minus 3, nothing to clean up there, equal to 16, 4 squared. So what's some conclusions we can draw? The center point, is it at exactly the numbers you see here? Or is it the opposite of the numbers you see here? The opposite. And my radius is the square root of whatever number is here. Okay? This is all we have to do is just write it in standard form. But if I give you an equation in standard form, we need to be able to read it and pull out this additional information. So in example 5, I've given you the standard form of the circle. What is the center of the circle? Where do you get those numbers from? H and K, which in this equation are what and what? Oh, I heard both -2 and +2. Which one is it? It should be opposite. It should be the opposite sign, which is this 2. And what about the y? -4. Because our formula has a minus sign in it, if you plug in a minus sign, it changes it to positive, and vice versa. So it's the opposite sign from inside the parentheses. Okay, if I keep going, what is the radius of this circle? 3, because the square root of 9 is 3. So my center is at 2, -4. My radius is 3. Let's see if we can graph this one. So I know I need to start. I'm going to zoom in. Oh, yeah, what's up?
Did you get the 3 from the 9?
Yes, I did. So remember, this is always, if I'm writing the equation underneath there, this is x minus h squared, and then y minus k squared equal to r squared. So if r squared is 9, that means it has to be 3 because 3 squared is 9. Yeah? To plot this, we go ahead and plot the coordinate point 2, -4, which is here. This is the center of my circle. As an aggressively large center, whatever, it's fine. Then on the cardinal directions, so up, down, left, and right, I'm counting what radius away? 3. So count 3 spaces away on the left, on the top, on the right, and on the bottom. I think I said left and right's backwards, but you get it. And then as nice and neatly as you can, you draw a nice circle. Okay, that was not my best. You don't have to say ew. I mean, it's not great, but you get it, okay?
And it's also
Thank you so much. I appreciate the compliment.
You're welcome.
10 points on your notes.
Thank you.
You're welcome.
We don't get grades on these.
10 points on your notes. Get it? It's funny. Okay, but this one has an additional question. It says, then use the graph to identify the relations, domain, and range. Ooh, let's remember, when I'm talking about domain, is that the x's or the y's?
X.
The x's, and the range is the? So I just want to identify which x's and y's I used. Very simple. You've already plotted the radiuses, radii. Between -1 and 5 on the x-axis, and between what two numbers on the y?
-7.
Very good. So if we were writing that in both set builder and in interval notation, just so we can have some variety here, the domain of this circle in set builder would be x such that it is between -1 and 5, or in interval notation, that's bracket -1 to 5. And the range in set builder notation would be y such that, I already forgot the number, it is between -7 and -1, or in interval notation, that's from -7 to -1. So again, that's the domain. Why did I put it in brackets? Does it actually touch -1 and -5? Like if it was an open circle there, that's when it would be parentheses. But it's, closed circle. I need to take all those flags down. There's another form of an equation of a circle, and it's called general form. If you remember when we learned general form of a linear equation, wasn't it always equal to 0? So look at what's happening here. What is this equation equal to? And they've got all of these things, x squared, y squared, an x, a y, a regular number, all on the left side of the equation. This is called general form for the equation of a circle. We can take the general form of an equation of a circle and rewrite it so it's in standard form. Because in standard form, we know the center, we know the radius. We know nothing in general form. But in standard form, we know everything. So we need to be able to take a standard form of the circle, general form, and convert it to standard form. The way that we do that is my favorite. We're going to complete the square twice in one problem. Can you hang on with me through that? Here we go. Possible. Thank you for the confidence. All right, we're going to use this general form and change it to standard form so that we can identify the center and radius and then graph the equation and talk about the domain and range. All of the things. Here's what we do first. I'm going to highlight like crazy on here. I'm going to highlight all of the terms with x's in them in red, pink, all of the terms with y in them in blue, and any regular number in green. I mean, red and pink are really close.
That's purple.
Swear.
Yes.
No, this is purple.
No, that's purple too.
I
I thought you were right.
am literally clicking a button. It's pink on here. Look, I'm going to come over here and show you that this is pink.
No, we've been following.
That's pink.
We've been following along with you with purple.
Oh, no.
Look at that screen. Tell me that isn't with purple.
Delete the purple line and then look at it.
Okay, y'all are actually making a good point. It's pink, though, on my screen. So sorry. It doesn't matter. Color-coded however you want. Okay, here we go. What I'm going to do is I'm going to put all of the pink stuff next to each other in my equation. So I'm going to have x squared plus 4x. I'm going to still call it pink, even though y'all are making me question my abilities to see color. And a box.
That one's pink.
That's the same color.
No, it's not.
Oh my gosh. Y'all are making me feel crazy. Okay, and then I have the y's. Here's y squared. And then -6y. And then blue box. I'm going to use a circle because I know not everybody has all the colors. So to show a difference, one of them is a box, one of them is a circle. Do you see how I've just put it all next to each other? I'm then also going to move the green stuff to the other side. When it crosses the center line, it changes sign. So it goes from being -23 to +23. Have we followed? All of the x's together, all of the y's together, the 23 by itself. We are going to, at this point, complete the square twice. We're going to complete the square so that I have a number to add on this side that would be in the box. Let me make that box look nicer.
Oh no, I don't get it. I really miss it.
I do too. I'm making it with the
It's 2 boxes, but in case you are not using multiple colors, I wanted it to look different. We got a box, we got a circle. We got to put a number in this box and in this circle.
Wait, those are 2 different circles on it? I'm confused now.
Are they zeros or just?
They're circles. They're like empty spaces. Think of it like a box.
Did you move these over or no?
No, I'm leaving a spot.
Oh, okay.
They will be the same number in the pink box on both sides.
For transferring both squares.
Yes, so we're completing the square twice. And when we completed the square, we had to add a number to both sides. So if we're doing it twice in one problem, we need to add 2 numbers. Let's complete the square for the pink. And it's pink.
Yeah, that one is pink.
4 divided by 2 squared, which is 2 squared, which is 4. So what number goes in both boxes? 4. I'm going to put a 4 in both boxes. We repeat for the blue. Negative 6 divided by 2 squared, which is negative 3 squared, which is 9. 9 goes on both sides in the blue box or in the blue circle. If you're sitting here going, what is this something divided by something squared? Add a note to yourself that when you complete the square, you have to remember to do b divided by 2 squared to find your magic numbers. That's what I'm doing in that step. I can read your mind. So here's the next step. The pink stuff is going to factor immediately to x plus 2, close parentheses, squared. Where did this 2 come from? Yeah.
When you factored it in.
Yeah.
In the second.
In the second part. That's why we show our work. I know it doesn't feel like we need to show that work, but it shows me the number I need. Then I'm going to add the blue stuff. In the blue stuff, it's going to be y minus 3 squared. Where'd the minus 3 come from? Yeah, before we squared it. And then all of this stuff on the other side needs to add together. 23 plus 4 plus 9 is 36. So wait a second. Doesn't this already look like it's in standard form? Yeah. Already I can tell you the center. Where is the center of this circle? Negative 2 and positive 3. What is the radius of the circle? 6. Voila. This is why we want standard form, because we know immediately where the center and the radius of the circle would be. This is standard form. It's double completing the square at the same time. If you want an additional arrow, this might be helpful. And this might not be helpful, so maybe don't draw it. But if you're like, where did all these numbers come from? That's where they went. Okay, so if we're plotting this one, we go at the center, which is at negative 2, 3. And then we count out a radius of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then we don't judge my ability to draw a circle, but we draw a circle. Eek. I don't want to hear it. Chocolate chip cookies are generally circular anyways, okay? Thank you, Brooklyn. Now we do want to know the domain and range of this circle, which y'all nailed it a second ago. The domain of this circle is all the values from negative 8 to 4 and all the values from negative 3 to 9. So we could write that domain and range, but we'll do that after lunch. Y'all go eat. Y'all can stop laughing at my circle over lunch. Right before lunch, we were looking at this one. All that we have left to do is write down the domain and range for this function. But we've already identified it. So if we're talking about the domain, we just want the x values where this graph shows up. In set notation, this would be x such that negative 8 is less than or equal to x, which is less than or equal to 4. And in interval notation, that's from negative 8 to 4. That's a negative. That doesn't look like it. Bless you. Oh my goodness. The sneezing. Everybody wash their hands. The range would be y such that negative 3 is less than or equal to y, which is less than or equal to 9. Or in interval notation, from negative 3 to 9. Yes. Okay, now that we had a whole break between lunch and this moment, let's look back at the beginning of this problem and address any questions we might have. So look back. See if you remember what we did. Bless you. Oh my gosh. See if you have any questions before I release you to practice on your own, because I would rather answer them now than later.